Hi, good day. Welcome back to our chemistry class. Today, I will be discussing about the balancing the redox reactions or balancing the reduction-oxidation reactions. I have already sent you a notes about this lesson and I want you to take out the notes with you now and try to browse and read it together with me as I'm going to discuss the notes that I wrote there. Now, what is important to take note in balancing redox reactions is that you have to take note whether the reactants have changes in their oxidation number as they form their products. In the notes that I gave you, there are two methods in balancing redox reactions. One is by the half reaction method, or this is known as the ion-electron method, and the second is by the oxidation number method or the molecular method. So let's start with the half reaction method. Now, this half reaction method, by the way, is true to a reaction which is in acid condition, in a basic condition, and in neutral condition. Now, there are steps to follow in balancing redox reactions which are in acidic condition. If you're going to look at your notes there, the very first step in balancing the redox reaction by half reaction method is that you have to establish half reactions. Now, when you're going to establish the half reactions, you have to see to it that the reactants will also form its corresponding product bearing the element or the atom in the reactant. For example, in the reaction between copper and a silver solution, let's say the silver solution here is an aqueous solution of silver nitrate. So the products formed are copper in the aqueous solution plus silver, meaning the silver is being displaced in the reaction. So if you're going to check the reaction, the copper here first is a solid. It is in the elemental states. It is in the free state, so the charge is 0. But when it forms its product, it forms a product which is in the aqueous solution. So this is already in the combined state. Thus, the copper has a charge of +1. And the silver is now being displaced. So as a product, it has a charge 0. Take note, the copper from a 0 charge, because it is in its free state, forming a product which is already in the combined state with a charge of +1. So there is an increase in oxidation number. Because there is an increase in oxidation number, this copper undergoes oxidation. Whereas the silver from a reactant which is in the combined state having a charge of +1, and when it forms its product, it's already in the free state, so has a charge of 0. Therefore, the silver in this case is decreasing in its atomic number. So it exhibits a reduction reaction. It is known that when there is an oxidation reaction, there is also a reduction reaction. So the two half reactions are copper forming copper ion, and the second half reaction is the silver ion forming a silver in the free state. So take note that there is a change in the oxidation number in both reactants. Now, let's have a specific reaction wherein the reaction is under an acidic condition. Our reactants are the dichromate ion plus the nitrous acid which is an aqueous solution, forming the chromic ion or the chromium ion plus the nitrate ion. In step 1, we are asked to write the half reactions. So the half reactions here will be the dichromate forming the chromic ion, and the other half reaction is the nitrous acid forming the nitrate ion. Now the second step after writing the half reactions is you are going to balance the reaction excluding the oxygen and the hydrogen. So if you're going to look at the reaction, you have the reactant dichromate. There are 2 atoms of the chromium and only forming 1 atom in the product. So what will we do? To balance the chromium, we're going to add 2 as a coefficient to chromium in the product. While in the second reaction, the non-hydrogen and oxygen reactant there is the nitrogen. Since there is only 1 nitrogen, so in the product, we have also 1 nitrogen in the nitrate ion. So it seems it's already balanced. Now, step 3 is, let's go to the balancing of the oxygen in the reaction. To balance the oxygen in the reaction, we have to add water to the opposite side where the oxygen is. In this case, the dichromate, which is Cr2O7, contains 7 oxygen atoms, while at the product there is no oxygen. Therefore, to the right side of the equation, which contains only the chromium ion, we are going to add 7 molecules of water. This is to balance the number of oxygen there are in the reactants. Now, in the second half reaction, take note that nitrous acid has 2 oxygen atoms, while in the product, there are 3 oxygen atoms in the nitrate ion. So, the reactant is deficient by 1 oxygen. Therefore, we are going to add water to the left side of the equation. That makes now 3 oxygen atoms. So, the number of oxygen in the second half reaction is now equal. Then let's go to step 4. Let's balance the hydrogen by adding a proton, which is the hydrogen ion. Take note that in the first half reaction, there are 14 hydrogen atoms in the product form. So, we are going to balance this by adding 14 hydrogen ions or protons at the left side of the reaction, meaning as a reactant, to counter the number of hydrogen atoms there are in the product. On the other hand, in the second half reaction, if you're going to look at the reactants, there is a total of 3 hydrogen atoms, while in the products, there is no hydrogen. So to counter this number of 3 hydrogen atoms in the reactants, wherein 2 hydrogen atoms come from the nitrous acid and the 1 hydrogen atom comes from the water molecule. So you have a total of 3 hydrogen atoms in the reactant, while there is no hydrogen atoms in the product. So we are going to balance this by putting 3 hydrogen ions or protons in the product. So your final half reactions will look like this now. For the first half reaction, you have now 14 hydrogen ions plus dichromate equals 2 chromic ion plus 7 water molecules. And the second half reaction, you have nitrous acid plus 1 water molecule equals 3 hydrogen ions plus the nitrate ion. Let's go to step 5. In step 5, we are asked to balance the charge of each equation with electrons. Now, If you're going to look at the first half reaction, that of the dichromate, there is 14 positive hydrogen ions. You have 2 negative ions, that of chromium. You have in the product forming a total of 6 positive ions of the chromic. So at the left side, if you're going to get the total positive charge, you have there 12, because 14 plus minus 2 of the dichromate will give us 12. While in the product, you have only 6 positive charges. Now, in order to balance this, our reactant will be added with 6 electrons, so that that 12 plus the 6 negative particles or the electrons will give us 6 positive charges. So the equation will become now 6 electrons plus 14 hydrogen ions plus the dichromate ion equals 2 chromic ions plus 7 water molecules. That is for the first half reaction. Then let's go to the second half reaction. That involves the nitrous acid and the water molecule. If you're going to look at the total charge, there is a total positive charge of 2. That is from the 3 hydrogen ions plus a negative charge of the nitrate. So you have there 3 plus minus 1 equals plus 2. Now, because there are 2 positive charges found at the right side of the equation, so we have to add 2 electrons to the right side of the equation to make it a balance of plus 3 and plus minus 2 equals 0, because at the left side of the equation of the half reaction, there is no total positive charge. Let's go to step 6. In step 6, we are asked to check the number of electrons there are in the half reactions. Take note, in the first half reaction, there are 6 electrons, while in the second half reaction, there are only 2 electrons. Now, how can we cancel out the 6 by a 2? Now, we are going to scale them up, meaning we are going to multiply the number of electrons in the second half reaction by 3 in order to make the number of electrons 6, so that you can cancel out the number of electrons in the first half reaction with that of the second half reaction. So the second half reaction will look like this. 3 nitrous acid or HNO2 plus 3 water molecules equals 9 hydrogen ions plus 3 nitrate ion plus 6 electrons. That is after multiplying the second half reaction by 3. So the number of electrons now in the first half reaction and in the second half reaction is the same. Now in step 7, we are asked to add the reactions and cancel out common terms. In this reaction, the common terms are the 6 electrons which are found in the first half reaction, and you have the 6 electrons which is also found in the second half reaction. So you can cancel them out. The number of hydrogen ion in the first reaction is 14, while that in the second reaction you have 9. So you can cancel out the 14 by a 9. So when you cancel out 14 and 9, you have a remaining hydrogen ion of 5 hydrogen ions. And you have to write the dichromate ion equals 2 chromic ion plus 4 water molecules. Finally, the reaction will look like this now. Look at your notes. 3 nitrous acid plus 5 hydrogen ions plus the dichromate ion forming 3 nitrate ion plus 2 chromic ion and 4 water molecules. So that is how to balance a redox reaction under acidic condition. Then let's go to balancing a redox reaction under basic condition. The steps to be followed in balancing a redox reaction under basic condition is a little bit similar to that of the balancing a redox reaction under acidic condition. The only difference is that there is the additional step number 8, 9, and 10, because we know that when bases dissolve, they will dissolve into hydrogen ions. Like, for example, the sodium hydroxide, when we are going to dissolve that, it will really dissolve into sodium ion and the hydroxyl ion. So, in step 8, we are asked to add hydroxyl ions. So, let's take, for example, a specific reaction. Kindly look at your notes which I gave you. We are asked to balance the following redox reaction in basic condition. For example, in this reaction, look at your notes. You have silver plus zinc ion this is already in the combined state, forming silver oxide plus the zinc in the free state. So again, this is a displacement method. So what are you going to do first? In the half reaction method, we are asked to write the half reactions. So the two half reactions are the silver forming a silver ion and the zinc ion forming the zinc in the free state. So look at the first half reaction and you have the second half reaction. The next thing that you're going to do is balance the atoms or the elements, excluding the oxygen and the hydrogen yet. So if you're going to look at the first half reaction, you have only there silver and silver oxide. In the product, there are 2 silver atoms. So we are going to balance this by putting a coefficient of 2 in the reactant. And in the second half reaction, if you're going to look at it, you don't have an oxygen there. You have there the zinc ion forming the zinc metal. So the number of zinc there is the same. So you do not need to put any coefficients. Let's go to step 2. In step 2, we are going to balance the oxygen and the hydrogen. Remember, in balancing the oxygen and the hydrogen, the oxygen is to be balanced by adding water molecule, while the hydrogen is to be balanced by adding hydrogen ion. So let's go to the first half reaction. That is silver forming a silver oxide. There is the presence of oxygen in the product. Therefore, because there is oxygen in the product, let's put 1 water molecule in the reactant to balance this number of oxygen that is formed in the product. Since there is only 1 oxygen in the product formed, so we will add only 1 molecule of water in the reactant. So the number of oxygen atoms now is the same. In the second half reaction, there is no problem because there is no oxygen involved. Let's go to step 4. That is, balance the hydrogen by adding protons. So the proton here actually is the hydrogen ion. Take note that in the half reaction, the first half reaction, there is already the addition of water molecule. So there is the presence of the hydrogen. And because there is already the presence of the hydrogen, so we have to counter this hydrogen in the reactant by adding hydrogen ion in the product. Since there are 2 hydrogen atoms in water molecule, so we will add 2 hydrogen ions in the product. So it's already now balanced. Now, step 5 tells us to balance the equation with electrons. Now, the electrons are to be added in order to counter the number of positive charges there are in the reactions. So, in the first half reaction, wherein you have the silver forming the silver oxide, you have there plus the hydrogen ion, which is 2. Therefore, this product has 2 positive ions, while in the reactant there is no positive ion. Therefore, in the product of the first half reaction, you have to add plus 2 electrons because you have their 2 positive ions to be cancelled out by adding 2 electrons. Why? Because 2 positive ions plus 2 negative particles, which are the electrons, will be 0. We have to make it a 0 because in the left side of the reaction, there is no total positive charge. Look at the second half reaction, that of the zinc. We have the zinc ion forming the zinc metal or the zinc in a free state. Since there are 2 positive ions, therefore, in the left side of the second half reaction will be added with 2 electrons. That would make a total charge of 0 because you have the plus 2 charge of the zinc plus 2 electrons which are negatively charged. Therefore, it makes 0. So this is now a balanced half reaction because you have a 0 total positive charge in the reactant and you have a 0 positive charge in the product. Then let's go to step 6. We are asked here to scale the reaction so that they have equal amount of electrons. In this case, it is already done because the number of electrons is the same. You have 2 electrons in the first reactant and you have 2 electrons which are also found in the second half reaction. So they can be cancelled out. Why? Because you have 2 electrons in the product of the first half reaction and then you have 2 electrons in the reactant of the second half reaction. Then let's go to step 8. Add hydroxyl to balance hydrogen ion. Add hydroxyl to balance the hydrogen ion. So this makes the difference in balancing redox reaction in the acid medium or acid condition with that of balancing a redox reaction under or in a basic condition. So let's add hydroxyl to balance the hydrogen ion. If you remember, look at your notes. If you remember, you have 1 water molecule plus 2 silver plus zinc ion forming zinc plus silver oxide plus 2 hydrogen ion. Now we are asked to add hydroxyl ion in order to balance the hydrogen. Since we have 2 hydrogen ions in the product and we have also hydrogen atoms in the reactant, to cancel out or to balance this hydrogen, we have to add 2 hydroxyl ion at the left side of the equation and we have to add also 2 hydroxyl ion at the right side of the equation. After adding or after putting the hydroxyl ions, let's go to step 9. That is to combine the hydroxyl ions and the hydrogen ions that are present on the same side of the reaction. After putting the hydroxyl ion, let's go to step 9, which tells us to add or combine the hydroxyl ion with that of the hydrogen ion in order to form a water molecule if they belong to the same side of the equation. So let us try to check. When you're going to look at the left side of the equation, you have 1 molecule of water, but you don't have any hydrogen ion there to form water molecule because there is only a hydroxyl ion at the left side of the equation. Whereas if you're going to look at the right side of the equation, you have there 2 hydrogen ions plus 2 hydroxyl ions. Now, these 2 hydrogen ions and 2 hydroxyl ions can possibly combine in order to form 2 molecules of water. So, you have now the equation which is 1 molecule of water plus 2 silver plus zinc ion plus 2 hydroxyl ions forming zinc plus silver oxide plus 2 molecules of water. Now, we are asked in step 10 to cancel out similar terms. So, you can cancel out the water in the reactant, which is 1 molecule, against the water in the product, which is 2 molecules. So, when you cancel that out, what is left in the equation now is 2 silver plus zinc ion plus 2 hydroxyl ion forming 1 zinc plus silver oxide plus 1 molecule of water. So that is how to balance a redox reaction under a basic condition or in basic condition. Reactions can also occur in neutral condition. Many reactions that occur in neutral conditions. Say, for example, the formation of ferric chloride, from copper aqueous solution with the addition of iron. So, if you're going to balance a redox reaction under neutral condition, we have only 3 steps to follow. So this is a little bit easier as compared to the first 2. For example, we have the reaction between copper and iron. So copper in the combined state has a charge +1. So taking the cuprous or +1 state, while the iron acting as a free element has a 0 oxidation number, forming a ferric ion plus the copper in the free state. So the reaction is copper ion plus iron in the free state, forming the ferric ion, that is iron +3 charge, and you have the copper in the free state. The first step is to make a half reaction. So the half reactions here involved are, first half reaction is the copper ion forming the copper free element, and the second half reaction is the iron in a free state or as an element forming the iron +3 or the ferric ion. Now, step 2 is you are going to balance the equation with electrons. Take note that the copper, which is +1, forming a copper in the product, which is 0. So we have to add in the reactant 1 electron, so that the +1 of the copper plus 1 electron will become 0 charge. That would be balanced now with the copper in the product. The second half reaction, we have iron, which is 0, at the left of the reaction, forming iron in the ferric +3 charge. So there are 3 positive charges in the product. That means we're going to add 3 electrons in the right side of the reaction, so that the +3 plus negative electrons, so that the +3 charges plus the 3 electrons will become 0. Now, let us scale up the number of electrons contained in the half reactions. Take note that there is only 1 electron in the first half reaction, while there are 3 electrons in the second half reaction. So what will we do in order to cancel out this number of electrons? So for the first reaction, we're going to multiply that by 3 to make the number of electrons 3, so that you can cancel that out with that of the second half reaction. So what will happen to your first half reaction? This will become now 3 copper ion plus 3 electrons equals 3 copper in the free state. So you have now the number of electrons is 3. And you add this or combine this with the second half reaction, which is iron forming the ferric, which is plus 3, plus the 3 electrons. So combining these two, you can cancel out the number of electrons, which is 3. So what will be the final reaction? So canceling out the number of electrons, the equation will become 3 copper ion plus iron in a free state equals 3 copper in the free state plus ferric ion. So take note that there are 3 positive charges at the left side of the equation. That is also a balance with the 3 positive charges of iron at the right side of the equation. So those are some examples of balancing a redox reaction by the half reaction method or the ion-electron method. Let's go to the second method of balancing a redox reaction. That is by the oxidation number method or the molecular method. In this case, what is important to take note, of course, is you have to take note the number of charges. You have to take note of the change in the oxidation number of the reactants as they form their products. For example, in the reaction between ferric oxide added with carbon monoxide forming carbon dioxide plus iron, take note what are the reacting substances here that exhibits a change in oxidation number. So the first step that we are asked to do is to assign the oxidation number of each atom involved in the reaction. Remember to assign the oxidation number of each atom involved in the reaction. So look at the first reactant. Iron is taking the plus 3 charge. Oxygen, we know, has a charge of -2. In the case of iron, there are 2 oxidation states which this iron commonly exhibits. We have the +2 charge and the +3 charge. In this case, the iron is using the +3 charge. Now in ferric oxide, the oxygen here is charged -2. Plus carbon monoxide, carbon is taking the +2 charge here, while the oxygen remains to be -2. And the products formed are carbon dioxide. So the carbon here in the product takes the +4 charge. The oxygen takes again the same charge, which is -2. Plus, you have the formation of iron in the free state. So the iron here is charged 0. We know that all elements have a charge 0. Now, what are the atoms or elements that exhibit a change in oxidation number? Look at the reaction. Isn't it iron exhibits a change in oxidation number, as well as carbon also exhibits a change in oxidation number? But the oxygen is not exhibiting a change in oxidation number. That means the iron and the carbon are the only atoms or elements which are involved in the oxidation reduction reaction. Oxygen is not, because oxygen does not change its oxidation number. After noting or writing the oxidation number of each element in the reactants and in the product, let's take note which of these elements exhibit a change in oxidation number. Now, if you're going to take note, the iron in the reactant as iron +3 forming iron in a free state which is charged 0. So from +3 to a 0 in the product, there is a decrease in oxidation number. because there is a decrease in oxidation number. That means it undergoes reduction, because reduction is further defined as where there is a gain in electron. So meaning in this reaction there is a gain in electron, but there is a decrease in oxidation number. Whereas in the case of carbon, from a carbon plus 2 charge to a carbon plus 4 charge, there is an increase of 2. So an increase is an oxidation reaction, because an oxidation reaction is also otherwise defined as where there is a loss of electron. So as the electron or as the element becomes more positive, meaning there is a loss of electron. But if the element becomes more negative, there is a gain of electron. Now, the carbon undergoes an oxidation reaction. If you're going to look at the change in oxidation number, they are not the same. For iron, there is a change of 3, but for carbon, there is a change of 2. So how can we cancel this out? How can we make a balance with these two? If you're going to look at the change in the oxidation number, that of iron is 3, while that of carbon is 2. Now, they are not the same or they're not equal, but we are asked in step 4 that these two must be equal. So in order to make this into the same, we're going to multiply that of iron by 2. So that 3 times 2 will become 6. While that of carbon, we're going to multiply that by 3 in order to make it 6. So the number of oxidation number change is now the same, which is 6. Now these multipliers, which are 2 of iron and 3 of carbon, is the coefficient that we're going to write into the reactants and in the product to make it balance. So because we multiply carbon by 3, so you put that 3 as a coefficient of carbon monoxide, and also write the 3 as a coefficient of carbon dioxide. So they are now balanced. What will happen to 2 as a multiplier of iron? If you're going to look at the left side of the reaction, you can see that iron is already 2. There are 2 atoms of iron. But in the product, you have only 1. So you place this 2 as a coefficient to iron in the product. So the final equation will look like this. Ferric oxide or Fe2O3 plus 3 carbon monoxide will form 2 iron in the free state plus 3 carbon dioxide as a gas. So that would be all for today about the balancing of redox reactions by 2 methods. We have already discussed that. And I will be sending you an exercise. And by next meeting, I'm going to give you a quiz about oxidation, reduction reactions, and balancing these reactions. That would be all, and this is your teacher, Professor Nisitas Ruiz of Holy Name University.